Today, we're diving into 3 striking new AI papers from Microsoft, Peking University, Alibaba Group, and top Chinese universities that push generative media in bold new directions. We'll look at Echo Infinity, which can generate video for over 24 hours with evolving memory, Lens from the Microsoft Lens team, a surprisingly efficient text-to-image model, and LoomVideo, a unified system for video generation and editing that blends text, images, and source video. Stay tuned for the ideas reshaping how AI creates. Let's explore the first paper, Echo Infinity Learning, Evolving Memory for Real-Time Infinite Video Generation. Echo Infinity, developed by researchers at the Chinese University of Hong Kong, Joy Future Academy at JD, Tsinghua, HKUST, HKU, Peking University, and USTC, tackles 2 bottlenecks in autoregressive video diffusion transformers: unbounded KV cache growth and temporal ropey overflow. The key idea is a learnable, evolving memory built from memory queries, trainable tokens that are updated whenever old frames are evicted from the local window through cross-attention, plus a sigmoid-gated residual, so the model filters, abstracts, and compresses arbitrary length history at constant cost instead of relying on fixed window truncation or heuristic compression. Echo Infinity also introduces a unified relative ropey recipe that anchors sync frames at temporal ID 0 and keeps all active indices within the pre-trained range during both training and inference, eliminating the train-test mismatch seen in prior test-time-only rope fixes, such as Infinity, Rope, and MemRope, built on the WAN 2, 1, T, 2, V, 1, 3, B backbone with causal forcing and DMD distillation. The system reaches 18.5 frames per second while generating more than 1.3 million frames over 24 hours on a single NVIDIA H100. On VBench Long and MovieGen, it improves 3.0 second user preference to 59.53% versus 14.73% for Memorize and Generate, and 2.40 second user preference to 71.67% versus 14.13% for Infinity, Rope, while also achieving state-of-the-art 5-second and 6.0-second interactive results. Ablations show both the memory queries and unified relative ropey are essential, with removing memory queries sharply reducing consistency and dynamic degree. Let's explore the second paper, Lens, Rethinking Training Efficiency for Foundational Text-to-Image Models. Lens, from the Microsoft Lens team, is a 3.8B parameter foundational text-to-image model built to cut training compute without sacrificing quality. Its core result is efficiency. Lens matches or exceeds larger open-source systems such as ZImage, Longcat Image, Flux, 2, and Qwen Image on benchmarks, including 1IG, Geneval, Longtext, and CVTG, while using only about 19.3% of ZImage's pre-training compute. The gains come from 3 design choices: Lens, 800M, and 800M, paired dataset captioned by GPT-4, one with dense 109 word average descriptions, mixed resolution and mixed aspect ratio training over 512 squared, 768 squared, and 1024 squared buckets, which gives the model generalization up to 1440 squared and aspect ratios from 1 to 2 to 2 to 1, and convergence-oriented architecture choices, especially the Flux, 2 semantic VAE, and the GPT OSS 2.0B A3B language encoder, which also enables multilingual prompt following from English-only training. After pre-training, Lens uses diffusion NFT reinforcement learning on Lens RL 8K, an 8,406 prompt taxonomy balance set with GPT-4. 1. Mini rubric rewards to reduce artifacts and improve alignment. A reasoner module with training-free system prompt search refines user prompts, and a distilled Lens Turbo variant reaches 4. Step generation in 0.84 seconds on a single NVIDIA H100 versus 3.15 seconds for the 2.0 step model at 1024 squared. Let's explore the third paper, LoomVideo Unifying Multimodal Inputs into Video Generation and Editing. LoomVideo, developed by Peking University and Alibaba Group, is a 5B parameter unified video foundation model for both generation and editing that targets interleaved multimodal inputs such as text, reference images, and source videos. Its key novelty is replacing the standard text encoder with Qwen3, VL, 8B, Instruct, and using a deep stack injection mechanism that extracts hidden states from every MLLM layer and injects them into the corresponding diffusion transformer layers via cross-attention, improving semantic alignment without heavy adapters. For editing, LoomVideo avoids the token concatenation strategy used by prior unified models like LoomVideo and Vino. Instead, it introduces a zero overhead scale and add conditioning scheme that directly adds a time-step scaled clean source latent to the target, noisy latent, eliminating sequence length blowup, and enabling at least 5.4 one-times faster inference. It also proposes negative temporal ropey indices to cleanly distinguish multiple reference images from video frames. Trained in 3 stages on roughly O10 MISID image text pairs, O10 MISID video text pairs, O10 MISID image edit samples, O3 MISID video edit samples, plus reference-guided and multi-reference data, and further improved with diffusion NFT reinforcement learning using PixScore, LoomVideo achieves state-of-the-art or highly competitive results on vBench, OpenVBench, RefViBench, and Intelligent VBench, with especially strong gains in e-commerce and fashion scenarios on the new Fashion Video Bench. That's a wrap on today's AI paper highlights. Thanks for watching.